Hello students, we will continue with the triple integrals in spherical coordinates. How to set up the limits of integration. That's what we are going to discuss now. So, suppose the domain D of the function f is given by this figure. Now draw a line M starting from the origin and that passes through the domain D. So as rho increases, that means as the distance from the origin to the point, arbitrary point P increases, the line or the ray enters the region D when rho equal to g1 of phi comma theta and leaves the region D when rho equal to g2 of phi comma theta. So g1 of phi comma theta are the lower limits of integration and lower limit of integration, and g2 of phi comma theta is the upper limit of integration. So here triple integral over D f dv equal to by Fubini's theorem it is given by iterative integrals. So first rho varies, it varies from g1 of phi comma theta to g2 of phi comma theta. These are the rho limits of integration. Okay. So assume that there is a ray starting from the origin and passes through the region D. So leaving is the upper limit and entering is the lower limit. Now next is how to fix the limits for phi. So for a given theta, so this is the ray M which was not in the previous figure. Suppose the ray M starting from the origin makes an angle phi with the positive z axis. So this is the angle phi that the ray M makes with the positive z axis. Now if phi varies from in between two numbers, call them phi min and phi max, such that M has to pass through the region D, then the phi limits of integration are these numbers phi min and phi max. Okay. Now finally, how to set up the limits for theta. For that you look at the shadow region R on the xy plane and draw the projection M, the projection of M onto the xy plane, call it the ray L. So let L be the projection of M onto the xy plane. The line L sweeps over the shadow region R as theta varies from, let us say, theta equal to alpha to theta equal to beta. Then this alpha to beta, these are the theta limits of integration. Let us do an example. So example, let us choose a darker pen. So example is find the volume of the upper region D. I will write here. Find, this is not dark enough. Find the volume of the upper region D cut from the solid sphere. Solid sphere means it is given by an inequality. So rho less than or equal to 1. Sphere of unit radius means rho equal to 1. Solid sphere means rho less than or equal to 1. By the cone, phi equal to pi by 3. I hope that you know the equation of a sphere in spherical coordinates. You know the equation of a cone in spherical coordinates. Equation of a cone is given by phi equal to constant. Equation of sphere is given by rho is equal to constant. Similarly, you can have theta equal to constant. There will be something else. I want you to find out what is meant by theta equal to constant in spherical coordinates. Okay, so let us plot this objects. So first a solid sphere of radius 1. So this is x, this is y, this is z. So you have this is sphere of radius 1, upper portion, and you have a cone phi equal to pi by 3, its upper portion. So this is that cone. Now look at the common part. It is this part. So this is your region D. And I want to find out the volume of this. So volume is obtained by integrating the function identically equal to 1. So volume of D equal to, so answer, volume of D equal to triple integral over D, f is identically equal to 1, dV. But what is dV? It is rho square sin phi d rho d phi d theta. So what is the first is rho variation. Rho varies from where to where, then phi varies from where to where, and finally theta varies from where to where. This we have to fix. So what I have to do is, I have to draw a ray that starts at the origin. So this is the ray M, where it enters the region, that is the lower limit for integration with respect to rho, and where it leaves the region, that is the upper limit for integration with respect to rho. So here integral rho varies from where to where, lower limit is 0 and upper limit is 1. Rho square sin phi d rho. So phi is kept constant, theta is also kept constant. So sin phi is constant. like that. Then you have to integrate with respect to phi. Phi varies from where to where. So what are the phi limits of integration? So suppose this m varies in d. When phi equal to 0, it coincides with the z axis, and when phi equal to pi by 3, it coincides with this line as well as with this line. Actually these are not lines because these are drawn in R3. So phi varies from 0 to pi by 3. When phi varies from 0 to pi by 3, the whole cone will be obtained. So 0 to pi by 3, d phi. Now integration with respect to theta. Integral theta. So for that I have to look at the shadow region. What is the shadow region? Shadow region will be a circle. This will be the shadow region. It's a circle. So theta varies from 0 to 2 pi. For that circle region to trace out, the projection L of m must sweep from theta equal to 0 to theta equal to 2 pi. So these are the theta limits of integration. And when you evaluate this, so first integration with respect to rho, so rho square integral is rho q by 3, like that. Substitute the limits from 0 to 1. Then integration with respect to phi, integration with respect to theta. You evaluate this as iterated integral. So by Frobenius theorem, you can compute this, and the answer is going to be pi by 3. Thank you.